All right, guys, I'm going to go fast through this again. These first two are substitution problems, what we did right before we left. If we know y equals 7, then we can take y out of this and plug in 7 because that's what it equals. 7 equals 3x minus 2. If you can now make your teams, then you know that the 2 is the one that needs, the negative 2 is the one that needs to come over here and be positive 2. And then we get 9 equals 3x. We divide by 3. And you get x equals 3 and y equals 7. I'm not going to write down all these things to see if you're listening to them. Okay, so on the next one, on that one you need to tell us both the answers. What y equals is 7 and what x equals 3. On the first one, on the next one, y equals 2x. So I can take y equals 2x. So that means I can take y out of here and plug in 2x because they're the same thing. So if 2x equals 5x minus 6, then I can move the 5x over there, minus 5x. If you don't know why I did that, I've got a x team, an x team, and a number team. So I need this guy to move, so we put the blue boxes on the same side. And we get negative 3x equals negative 6. When I divide by negative 3, I get x equals positive 2 because the two negatives cancel out. But here's the trick. I'm not going to do this part. Now that you know that the x equals 2, you're going to take the x and plug it back in here into this equation. So you're going to replace the x with a 2. So y equals 2 times not x, but y equals 2 times 2. So now you know both answers. All right, I'm going to just do the first one. You should be able to do the next ones. In these, I've got 3 terms. I've got negative 6, 2, and negative y. Don't worry about the colors. For this one, you do whatever's outside the parentheses times everything that's in the inside the parentheses. So negative 6 times 2 is negative 12. Negative 6 times negative y is positive 6y because the two negatives cancel each other out. That's why you got to include the sign with it. Equals 30. Here I've got a number term, here I've got a number term, here I've got a y term. So the number term is the one that's going to take the hike. When it switches sides, it becomes plus 12 instead of negative 12. And we get 6y equals 42. We divide by 6, and y equals 7. All right, so same thing on those. Follow the steps. On 4 and 5, you should be fine. All right, for number 6, 7, 8, and 9, here's what I want you to do. I want you to write down this formula, the change in y over the change in x. Remember that the triangle means change. So if we look at number 6, y keeps changing by 50, or y, you could choose any 2 points you want. Number 8 might look weird because it doesn't change equally, but just trust me, take any 2 points you want. See how much it changes. So this is the change in y is 50, but we divide by how much the x side changes. Over here, it changes by 2. So the x's change by 2. So the slope of this line is actually 50 divided by 2 is 25. So how much these go up divided by how much those goes up. Always change in y divided by the change in x. So it might look weird once you get over here, but they're the same way. All right, these ones, I'm going to do one of them. Oh, I'll do 2 of them. This is the 10th spot right there. This is the 100th spot, so we had a 0, so this is 11 hundredths. There's nothing I can do from there. We're done. All right, for this one, I will tell you that's the 10th spot, so we have 6 and 8 tenths, but you need to reduce that. This is the 10th spot, so we have 9 and 4 tenths, but this line up here changes the bottom to 9ths, and you're done. All right, this one I'm going to let you do by yourself, sort of. Here's the 10th spot, here's the 100th spot, but the hundreds get changed because of the thing on top, the repeat sign, to 99. So let's see if you can do that. And once you do that, is there a number that goes into the numerator and the denominator? Can you simplify it? Hint, you can, yes. And finally, this one, negative. This is the 10th spot. This is the 100th spot. You think, okay, I'm done. 95 on hundredths, negative 95 on hundredths, but something goes into 95 and 100. So go ahead and try to figure out what number goes into 95 and 100 and take it out. All right, these ones, I'm just going to do the first one. For all of these, this is not estimate. This is not estimate. If I was estimating the square root of 18, I would say, oh, it's past 16, not quite to 25. It's probably like 4.2. But that's not what I'm doing. For these ones, what I'm doing to simplify, I'm going to break it up into 2 square roots that multiply to 18. And one of them has to come from my wall. One of them has to be a perfect square. So for 18, I'm going to look, okay, let's see. 16 is on my wall. No, that doesn't go into 18. If I keep moving down on my wall, I see number 9. Oh, that does go into 18. So this is 9 times 2 because 9 is on my wall. Remember, we would always do this one. This is the special one. And that's special because it has an answer. The square root of 9 is just 3. So this answer is 3 times the square root of 2. So you got to think of all the numbers that were on my wall. If you want some help, 1 is on my wall, but we never use it. 4 is on my wall. 9, 16, 25, 36, 49, 64, 81, 100. All right, so use those as your specials to see if you can multiply, and you'll get there. All right, next page. Let's see, graph y equals -1/2 plus 3. I'm not going to do this for you because I want you to graph it, but this is where you start. You should know where that is. I'll put a dot there. And this is how, ooh, I didn't put the x, did I? Shame on me. There's supposed to be an x right there. I'll have to make that announcement in class. So if I didn't make it in class, there's an announcement right there. All right. And it moves this down 1/2. You should be able to graph that. Over here, it starts here. And you should know that basically there's a 1 here, and if there's no 1 on the bottom, this just moves up 1/1. Okay, so graph those on the line. This one should start down here. The red one. Okay, let's see. Using the graph, solve the system of equations. So basically, what point on this graph is on both of these lines? So look for these 2 lines on the graph intersect and tell me that point. Let's say they intersected up here, right there. Then I would say that's at point 6, 6. That is not the truth. So if I see 6, 6, I know you're listening to this with your headphones off and you're just copying down what I wrote. So, yeah. All right, find the area. Super easy. Circles should be easy. Area equals pi r squared. We take the radius, we square it, and we put a pi on the back end. 7.5 times 7.5 pi, and then just do it in your calculator. All right, number 25, I can tell you don't pay attention to the 20, pay attention to the 10. That's the radius. And the area equals pi r squared, so that should be easy. Take the radius. All right, here's kind of a tough one. We're just finding the area of the green area. So if we take the big circle, let's imagine the big circle. That's 2, that's 2, that's 2, that's 2. So the green circle all the way across is 8, but we don't care about the 8. We only care about 4. So to find the whole big circle, the area equals pi r squared, but the radius is 4. Pi times 4 squared, area equals 16 pi. Okay, so 16 pi is that whole thing. But we need to subtract out these 2 circles. And they're the same size. So once I find one of them, I'm going to just multiply by 2. So let's try to find one of those circles, one of those small circles. I'll do it in blue. Area equals pi r squared. The radius is 2 for that little guy. So area equals pi times 2 squared. Area equals 4 pi. Okay, so if this is 4 pi in here, then this is 4 pi in here. So the big one was 16 pi, and we took away a 4 pi, and we took away another 4 pi. So 16 pi minus 4 pi minus 4 pi, because 4 pi is this circle, and the other 4 pi is this circle, so we just kind of took them out of there, and that leaves us with the green area, so the area is 8 pi units cubed. All right, over here, try to do the same thing. Let's see if you can figure it out. The big circle has, because this 2 over here, the big circle has a radius of 5. Oh, that was, I don't know what I was drawing there. And now my eraser doesn't work. Oh, there we go. So the radius for this guy, what is going on with my pen right now? The radius is 5. So when we try to take the big circle, we're going to say pi r squared, and we're going to use 5 as the radius. And then when we take out this middle square, we're going to subtract this middle square, so minus pi r squared, but the radius is just 3 for that guy. So we're going to take the big circle, and we're going to subtract the little circle, and that's going to leave us with just the green area. You can do that. All right, find the volume. What I would say to do is this area in here is the triangle. Figure out the triangle, and then stretch it backwards by 5. So we're going to go backwards by 5, backwards by 5. So can you figure out that triangle in the front? The area for the triangle is 1/2, because triangles are half rectangles. Base times height, we're going to use 7 as the base right here, this 7, because if that's the floor, then we know exactly how tall the ceiling is. So area equals 1/2, 7 as the floor, times 8 is the ceiling. Go ahead and do that math. And then you're going to, at the end, you're going to stretch it by 5, and that's going to give you your units cubed. All right, number 29. So to find these, we find the area of the circle on the bottom. Then we stretch it up as if it were like a cylinder. And then we crush in the top and divide by 3 because it's a cone. So start with the circle, stretch it upwards, crush it in. So this was a 3. So for the circle, pi r squared, we're going to say area equals pi times 3 squared. Area equals 9 pi. Area is 9 pi of the bottom. Now we're going to stretch it upwards 8 times because of that's how tall it is. We're going to take that and we're going to pretend we're going to stretch this circle up 8 times and make it 8 times bigger. But then you need to crush it inwards, and so that makes it 3 times smaller. So we're going to times by 8, and then we're going to divide by 3, which I believe is 24 pi units cubed. But show me that. I'm giving you hints. I'm not doing the whole thing. All right, number 30. Remember, this is volume equals, it's like a circle. If it was a circle, it'd be pi r squared, but it's not a circle. It's 3D, so we got to put pi r to the 3rd power. And there's that stupid fraction in the front. All right, so volume equals 4/3 times pi, and now we need the radius to the 3rd power, but the radius is 4, so that means 4 times 4 times 4 is 64. So in my calculator, I'm just going to multiply all of those. I'm not going to put it down here because I want you to do the work, but that's units cubed because it is 3D. All right, number 31, same thing as number 30, except we don't care about the 20. We only care about the radius is 10. So the volume is 4/3 pi, and the radius cubed. The radius cubed is 10 times 10 times 10, which is 1,000. So we've got volume equals 4/3 pi and 1,000. So go ahead and put those in your calculator and see what you get. All right, this one, simple. It's like 1 step less than a cone. We don't have to crush it. We just find the circle. Area equals pi r squared, and the radius is 11. That should be really easy. And then we're just going to grow it by 7. So should be easy. Same thing for 33. We don't care about the 10. We just care about the radius of 5. So we find the circle. And then we stretch it by, let's see, we're going to stretch it downwards 6. So we're going to let it grow 6 times. So we got pi r squared on the top, where the radius is 5. So 25 pi, and we're going to stretch it 6 times down. That should tell you how big it's going to get, and that's a volume, so it's going to be units cubed. Same thing for number 34. We don't care about the 10. We care about the 5. So if we're going to figure out, our steps are, we figure out the circle. We let it grow by 6, and imagine that it's this huge cylinder. Then at the end, we're going to say, no, we got to crush in the bottom and make it 3 times smaller. So we start with the circle. Area equals pi r squared. And then we're going to grow it by 5. Or sorry, not by 5, by 6. We're going to grow it by 6. And then over here, we're going to crush it in. So we're going to divide by 3. And that's units cubed. And Sudoku, good luck with that. All right, good luck. Hopefully you stay green.